Okay, for this review problem, we have the following theorem. If a and b are integers, then a divides b and b divides a, if and only if a is equal to b or a is equal to negative b. So this is an if and only if theorem, which means it'll have two parts. So first we'll do the first implication to show that the first statement implies the second statement, that either this or this. So we begin by assuming, suppose that a divides b and b divides a. Okay, now by definition we know that if a divides b, that means a cannot be equal to 0. Furthermore, if b divides a, that means b cannot be equal to 0. So by definition of divisible, we know that a does not equal 0 and b does not equal 0. And also a and b have to be integers, and that was part of the assumption of the problem. All right, that's a technical point that will become clear later, that why we need that. Okay, by definition, there are integers j and k, so that, well, from the first one, if a divides b, then I can write b is equal to a times j. Also, if b divides a, then I can write a is equal to b times k for some integers j and k. Substituting, we find that b is equal to, well, if b is equal to a times j, so if I plug in here, I get b times k times j, just by substituting. So b is equal to b times k times j. Now I'm allowed to cancel b on both sides because b was not equal to 0. So I can cancel the b's on both sides, and so 1 is equal to k times j. Now that's an important point. If b was equal to 0, then 0 can be equal to 0 times, say, 6, and then k times j could be equal to 6 or anything else. But because I know that b does not equal 0, I'm allowed to cancel b's on this step. So I'll make a note of this since b does not equal 0. So the product of two integers is equal to 1. Well, the only way that happens if they're both equal to 1 or if they're both equal to negative 1. That's the only way for the product of two integers to be equal to 1. So the only ways for the product of two integers, let me move this up so I can see it better. Product of two integers to be equal to 1 is if k equals 1 and j equals 1. That's one possibility. Or k equals negative 1 and j equals negative 1. So those are my two possibilities. All right, case 1. If k equals 1 and j equals 1. All right, so suppose k equals 1 and j equals 1. Well, if I come here, if k equals 1, then a is equal to b times 1. Or a equals b. So that's case 1. Case 2. If k equals negative 1 and j equals negative 1, then if I substitute in for k here, a is equal to b times negative 1, or a equals negative b. So I got those by using k. Alternatively, I could have used j equals 1 and j equals negative 1 and plug into the first equation. I would have come to the same conclusion. So let me just mention parenthetically, here if k equals 1, I plugged into this equation to get here, and that's fine. It would have been perfectly okay to plug in j equals 1 and j equals negative 1 into here, and I would have ended up with the exact same point. So, in conclusion, if a divides b and b divides a, then one of these two things has to happen, A equals B or A equals negative B. Okay, so this is an example of a proof by cases. One of these two cases has to happen, so I just kind of run through those and see what happens. So that's an example of a proof by cases. All right, now this is an if and only if. So let's go back to our original statement. A divides B and B divides A if and only if A equals B and A or A equals negative B. So I've done one direction, now we'll do the other direction. So the other direction. Suppose that A equals B or A equals negative B. I must end by showing that A divides B and B divides A. Case 1. Well, clearly, case 1, suppose A equals B. Then I can write B is equal to 1 times A, so that A divides B. If A equals B, then B equals 1 times A, so A times an integer is equal to B, and therefore A is a factor of B. Also, I can go the other direction. A equals 1 times B, so B times an integer is equal to A, so that B divides A. So A divides B and B divides A if A equals B. Case 2. Suppose that A is equal to negative B. That means that B is equal to negative A, which is the same thing as negative 1 times A. So A times an integer is equal to B, and so by definition, A divides B. Also, if A equals negative B, then A is equal to negative 1 times B, so that B divides A. Okay, so either way, if in case 1, A divides B and B divides A, case 2, if A equals negative B, then I have the same conclusion. Therefore, either way, if A equals B or A equals negative B, then I can make the same conclusion that A divides B and B divides A. And that's the end of the proof. So for a proof by cases like this, case 1, I come to the conclusion. Case 2, I come to the same conclusion. Therefore, either way, I come to the conclusion.